Let's talk about animation transitions. It's one thing to animate something, but does it feel right? Sometimes tweaking the transition of the animation goes a long way to make it feel super polished. A transition defines how an animation behaves from point A to point B, how fast it starts, the duration it takes to go to the final destination, and all of this, the easing curve, the spring physics, can be defined in motion in the transition prop. In this example, we have a pink square, and you can see it has two variants, big or small. So here's the motion.div in question. We have an isBig state, and if it's big, we're going to have the big variant, otherwise the small one. And let's watch it in all its glory. Here it is big, and here it is small. So honestly, as of right now, the transition already looks pretty nice. We haven't specified a transition property, but Motion is going to apply sensible defaults out of the box that look great, so you don't have to do anything to have a good-looking animation. You can see here the default animation has a little spring to it, and if you want to tweak this, you absolutely can. And the way you do this is by passing a transition prop to the motion component. Let's say we wanted a slower animation, maybe something that lasts for 1 second. So I can go duration 1. And this is going to opt out of the default spring animation in favor of a tween that lasts 1 second. Let's take a look. Start, finish. And in reverse as well. We are not using spring physics anymore, but even there with the tween, there is a default easing that looks better than nothing. And just to prove my point, what I mean by nothing would be an ease of linear, which is basically the same speed throughout the whole travel journey. So let's look at that again. And it's subtle, but you can see that it arrives at destination abruptly and it doesn't feel as nice and polished. Motion comes with plenty of built-in easing curves, so let's take a look at a couple. Let's try back in out. Interesting, you can see that it kind of winds up before and after the animation, giving it some sort of elastic overshooting effect. Okay, let's look at ease in. And with ease in, the transition will ease into its final destination, so it'll start slow and accelerate towards the end. And the counterpart, ease out, is going to do the opposite. It's going to start fast and slow down towards the destination. A very common go-to easing, because it looks great most of the time, is ease in out. And it's going to mix both together. It's going to start slow and end slow and accelerate in between. That usually feels pretty smooth. On top of the built-in easing functions, you can bring out your own cubic Bezier function when you want more control. So we've looked at a few of these built-in functions, and as you can see, you can use cubic Bezier by either importing the cubic Bezier function, but you can also pass an array that represents these cubic function values like this. Let's try that. And take a look at what it looks like. You can see that it feels sort of like an ease out, but if I was to increase the last number to say 1.8, it might not look great, but it's going to overshoot past the final destination. And as you can see, you have a lot of control here. You have a lot of control, yes, but you would be hard-pressed to create a super realistic, physics-like transition with easing curves. And this is where spring animations come into play. Let's get rid of our ease and duration in the transition, and instead we're going to opt in a type of spring. Again, this is going to come with sensible defaults that look, well, springy. That feels pretty nice. But now you've entered a whole world of physics-based animations that you can customize to your liking and are incredibly more powerful than transition with tweens. The easiest way, I'd say, to begin customizing a spring transition is using the bounce property. And you can think of that bounce as, well, how bouncy your spring is going to be. It's a value between 0 and 1, so if I go 0.2, we shall have a mildly bouncy spring. And actually, it almost feels like it's not a spring at all. But if I was to crank that up to 0.8, we'll now have an incredibly stiff spring. And you can see that this time it really does feel like a spring animation. Just for kicks, let's bring it up all the way to 1 and see what happens. Ready for the slingshot? I really like that. The bounce property is sort of a feel-based, vibes-based way to tweak a spring animation. If you want a more scientific approach based on physics, you can use property like stiffness, damping, and mass. This is a little harder to wrap your head around, but will give you great results. So if we set a stiffness quite high, let's go 1000, our spring is going to feel very stiff or sort of bouncy again. But then if we pair that with the damping property, which is sort of the opposite force going against the spring or the resistance against the spring, and we set that to, 10, quite low, we should have a very stiff spring that keeps on going for quite a while. Let's give it a try. Okay, so that's quite similar to what we would have gotten with bounce 0.8 or something like this. But now let me bring the damping to 1. And if you need another coffee, now is the good time to go and do it, because this is going to bounce for a little while, as you can see. We got a really stiff spring with not much resistance, and as a result, it keeps going and going. Now, if I go the other way and set the stiffness to maybe 50 and the damping to 30, we should have a completely different effect with a sort of soft, sloppy spring, which has a lot of resistance, so stops pretty quickly. And actually, the damping is way too strong for the stiffness here. So we've lost all sort of feel of a spring. Let's try damping of 3. And like I said, a bit harder to wrap your head around. But with physics-based springs, you can achieve all sorts of realistic object motion that you couldn't get close to with just tween animations. Okay, let's increase the stiffness to 400. Again, quite stiff and no damping, so it should bounce for a little bit. And we're going to add some mass to this. So what the mass does is basically, just like in real life, is going to add a lot more weight and inertia. So the object is going to start moving slower and take longer to stop. Imagine a big truck versus a small car. So the mass essentially gives that feel of weight. So the default value is 1. But if I was 10xing the weight of this transition we've just looked at, it's going to happen much slower. And you can see the weight is fighting against the damping. We have the same resistance, but 10 times the mass. So we would need to increase the damping by 30. If my math is right, let me refresh the page so we don't wait, to recreate the same sort of physics. And obviously, if the mass was 0.2, this thing would be very lightweight and the damping would stop it almost immediately. And I think I sort of understand what's happening. Okay, but what if you wanted to have a spring animation that still feels like a specific duration? Remember, with tweens, we could just set the duration to 1 second. Can we do that with springs? And the answer is yes, sort of, but it's a little bit more springy. Now, we can't bend the time in real physics, so let's go back to the bounce definition. And yeah, let's go 0.8 to have a very bouncy looking spring. Now I can control the duration of this animation. So if I wanted it to take 0.1 second only, this is going to be extremely fast. And if I wanted it to take 3 seconds instead, it's going to take 3 seconds to complete the animation. Let's try that again. Click. 1, 2, 3. The visual problem here is that a 3-second travel is very different for an object that goes back and forth a bunch of times, like we've seen with that spring, versus a tween that just goes once from A to B. And for that reason, if you want to align the animation feel with what a tween would do without counting the back and forth, you can use the visual duration instead. So this is going to use the first 3 seconds to travel to the destination, but then on top of that is going to continue the bounce. Obviously here we have a pretty bouncy spring, so it lasts forever. It's still moving a little bit. Let me change the values. So I will go all the way to 1, which is extremely bouncy, but we will set the visual duration to be 1 second only. Let's do it. All right, and so you can see that because the stiffness or the bounce is so dialed in, if we stretch out the first part of the travel to 1 second, it's going to drag everything extremely long. Whereas if we had 0.1 for the first travel bit, the behavior would be quite different. So you can think of the visual duration in taking the first sling of the spring and using that duration for that segment. And then whatever happens after will be basically set to the speed of the original stretch that you've done. All right, let me get rid of this visual duration and go back to 0.8 for the bounce. Now I want to show you something super cool, and it's the fact that you can have different transition styles using springs for different properties. So if we look at our variants, you can see that we animate the X property and the scale. And right now we're applying the same transition type and bounce, but I could scope out the spring to the X property only by moving it inside the X key. And now watch what happens. Sort of funny, right? Let's look at it again. You can see that the X-axis, the translate X, is bouncing like a spring, but the scale is actually using a fairly linear approach, the default settings. And if we were to flip that to use the spring for the scale only, try to guess in your head what it's going to look like. The scale should go up and down, but the X translation should be quite linear. Did you get it right in your head? I sure didn't. So let's keep the scale like this, and for the X, let's go with the type of tween and a duration of 2 seconds. And let's take a look at what this looks like. Not necessarily great looking, but you can see that you can combine spring animation with tweens between different properties and basically have a lot of flexibility. I actually thought the result we had from that combination was pretty cool, and that's something I would use in my websites. All right, we got to wrap it up soon, but I want to show you a couple more things. I want to show you the delay property, the repeat and repeat type properties as well. Okay, so for delay, actually, I'll bring back the X transition, and I'll keep the original easing, but I will add a delay of 0.5 seconds. So now the X translation should wait half a second before starting. And yep, that's looking pretty cool. What if we wanted the scale to occur only once, like now, but the X translation should happen 3 times? I will add a repeat property, and not add 3, but add 2, because it's going to repeat twice after the original one. Let's look at it. Click. First. Okay, so it did repeat 3 times, but it looked pretty jarring because it always started from the start position again and again. And this is precisely where the repeat type property can bring you better results. Right now we're in loop mode, but if we were to go mirror, it's going to ping pong back and forth, which probably will look better. Let's try it again. 1, 2, 3. And you can even have more control between the repeats. So if I type repeat, you can see that we have a repeat delay. So if you wanted to wait 0.5 seconds between each repeat, we're now delaying our X translation by half a second. We then repeat it twice with the mirror style, and we add a delay of half a second between each repeat. And the final result for this is that. 1, wait, 2, wait, 3. And this time, I'm gonna wrap it up. I could play all day with tweaking spring animations in transitions. This is awesome, super powerful, and you can drastically change the look and feel of an animation with subtle tweaking.